light up a 2.5 volt torch bulb using a 1.5 volt electric cell in an experiment. We simply have to connect the positive terminal of the cell with any one of the terminals of the bulb. And finally complete the circuit by connecting the negative terminal of the cell to the second terminal of the bulb. The bulb then glows. The word circuit is very important here. In this context, it will be electric circuit. In simple words, it is the path along which an electric current can flow. You can see here that a closed loop is formed. All the terminals of the electric cell and the bulb are occupied. So here the electric current is flowing along a closed path. We say that electric circuit is complete. But how exactly does electricity flow through the circuit? Well, it is difficult to explain how exactly it flows. However, I will try to give you an intuitive explanation of this phenomenon. You will learn more details in your higher grades. Basically, it's said that electricity or electric current is a flow of electrons in one direction. What really happens is that the negative terminal of the cell repels the electrons in the copper wire near it. So the electrons in a copper wire drift away from the terminal. But in the process, they repel their neighboring electrons. Or in other words, they transfer some of the energy to their neighboring electrons. So the neighboring electrons are also pushed away. They in turn further transfer the energy to their neighboring electrons. The process continues and the energy flows throughout the circuit. This flow of electrical energy is nothing but electric current. So these are the two ways to define electric current. This one is more accurate of the two. In reality, electrons don't really travel from the negative terminal all the way to the positive terminal. The electrons merely drift slightly from their rest position and transfer the energy to their neighbors. This is because the wire is a solid object and the density of atoms per unit volume is very high. Hence, there is no space available for electrons to travel all the way through. So it is this electrical energy that travels through the circuit. But how does the energy flow through the bulb? The electrons in the copper wire transfer this energy to the electrons in metal rod connected to one of the terminals. This energy then flows through the rod, through the filament and out from the second terminal. So in this way, the energy is transferred through the bulb. But when the energy flows between the two ends of filament, it heats the filament up, which in turn glows and gives off light. So I hope that you're now clear about how the electricity travels through a circuit. But for how long will this energy keep flowing? The energy flows as long as the circuit is connected or until the cell dies out. So we learned that the circuit must be complete for the bulb to light up. But is this the only way for the circuit to be complete? Well, if we interchange the wires connected to the two terminals of the bulb, then the circuit is still complete. So the bulb will still glow. Now look at this circuit. Is it complete? No, it isn't. Not all the terminals of the system are occupied. For instance, this terminal is not connected to the circuit. Here both positive and negative terminals of the battery are connected to only one terminal of the bulb. So what's happening here? The energy is flowing from the negative terminal of the cell directly to the positive terminal of the cell. Not only will the bulb not glow, but it will get even worse. The battery might explode and may severely injure us. You should never connect the positive and negative terminals directly. This heats up the wire quickly, and at the same time, the battery also drains really fast.